Okay, so I have the route of the west, I have the route of the east, and I know that at this point right here, they're going to be 60 miles apart. Okay, and that's from the problem. And this is where I want you to get, so don't worry about this stuff, I'll introduce it in just a moment. All right, do I know how far the westbound bus went? Do I know how many miles it went? Does it say in the problem how far it went? No. Does it say how far the eastbound bus went in miles? Nope. But did it tell me that the distance of the westbound plus the distance of the eastbound should equal to 60? That is something they gave me. And you're like, how did they give it? Well, in the diagram hopefully explains it more, but I know that these two distances combined should be 60 miles. That's how I got this stuff. Okay? Everyone good on that? So far at least? Okay. How many of you know the distance equals rate times time formula here? Have you ever seen this before? D equals RT? Okay, so write these things down real quick. What does distance stand for? Or sorry, what does D stand for? Distance. What does R stand for? Rate, which is also known as speed. And what's T stand for? Time. Okay, so that's all what those letters stand for. So get that down, please. Yeah, this is key to these problems. Yep. Okay, I'm going to go with the purple again. All right, once you have this down, I'm going to start on the next part. What have we done on each one of these word problems so far? We've created a chart or a little table. Good. So we're going to create another one. And this one's going to be a little bit less complex than the other ones, all right? So here's my table or chart, and I'm going to split it up into 3 columns and two rows here. So just like I did on the other problems. So you see the similarity already? Okay, what 2 objects are moving in this problem? The 2 buses, right? I'm going to call one the eastbound bus, the EB, and one the westbound bus, the WB. Okay, so WB and the EB are the eastbound, westbound. Okay. Now, what are going to be the headings of these problems? When you're dealing with uniform motion problems, remember how I told you need to know D equals RT? The reason I want you to know that is because that's going to be your heading. This is how it goes. You're going to put R, T, D. And how do those relate again? How does R, T, and D relate? Josh. Okay, please remember that. R times T equals D. That's good. All right, do I know the rate of the eastbound bus, or do I know the speed of the eastbound bus? Hayes? The eastbound. 35 miles per hour. That's what goes in there. Do I know the speed of the westbound bus? Benson? 45 miles per hour. So that wasn't too bad. I got the R's. The T's are a little bit more difficult, but I hope you can get it. The time. Did they tell me how many hours it took for them to be 60 miles apart? Nope, didn't say that. That's what we're trying to find. But did they mention anything in the first sentence about time? So I would look at the first sentence and like, They leave at the same time. So they were at the bus station and they started and left at the same time. So you know what I know about those 2 times? They're the same. Whatever that time was, it was the same. We'll just put T and T for time. That's nice. Okay, this is, if you can remember what happened in the past, what do you do to get this last one? Think of the formula or think of yesterday. You did something to get that last column. Eli? Yeah, what's 35 times T? 35T, how nice. And what's 45 times T? 45T. We know the distance of them both together, and that's actually where I'm going to pull up next. So all I have is this chart fill. I'm like, okay, what does that do to help me out? Okay, I'm going to scroll up just a little bit. What do I know about do I know the distance of the westbound bus? Like, do I know how many miles it traveled? Yes. Yes and no. What do I know about the distance? It is, it's 40, whatever it is, it's 45T. So watch what I'm going to do here. I'm going to create an equation. 45T is the first part of my equation. And that's a T, and I'll try to make the plus different. What's the distance of the eastbound bus? Well, I don't know how many miles, but I do know it's 35t. Oh, see, and this is where I got to keep it straight. Plus 35t. And what do I know about the distance of the westbound plus the distance of the eastbound? It's going to give me. So that's why I know that these two quantities are going to give me 60. So you kind of see how those relate a little bit? Yeah. Okay. Solve for t. So get t by itself. And you're going to get a fraction, and that's okay. So get your fraction, and then you'll get your answer on that. And don't forget your units. Like, what units would you deal with? Okay. So what's 45t plus 35t? 80t. So I have 80t equals 60. And then what do you have to do to both sides here? Divide by 80. Uh-oh, that causes a problem. Thankfully in this problem, it won't. What's 60 over 80 reduced? 3 over 4, which is what unit, for time in this problem? Is it seconds, minutes, hours, days, weeks, months, years? What is it? Hours. So 3/4 of an hour, which is also known as? What's 3/4 of an hour?
45 minutes.
45 minutes. Okay, ready? I'm going to summarize this problem here now that we have an answer. It's an in answer. Okay, stations right here. The westbound went. The eastbound went at the same time. And when they were 60 miles apart, how long had it been since they left? 45 minutes. That's all you're trying to say there. Does that make sense? It took them less than an hour to be 60 miles apart. Okay? It will get harder. It will be, thankfully. I won't give you problems that are like 0.16 hours. So there'll be fractions that reduce to nice easy ones or whole numbers. These problems will get difficult because this is what's going to happen. I'm not giving you this problem today, but please pay attention. You're going to start at the same bus station. One's going to leave 3 hours before the other. And then they're going to ask you, when are they 300 miles apart? So you see how that's a little different from this one? One started 3 hours earlier. So you know what changes? All that's going to change in that problem is one of these is going to have to change. Or here's another one. One would have to be t plus 3 or t minus 3, depending on which one left. One of them will be, they both start at the same point, and they both leave at the same time, but one's going faster. When are they going to be 60 miles apart? So they both had the same time, but their distances are going to be different. But it's really not that bad if you get this one already. But there are different problems. I won't give you that today.
They're going side by side. One takes a diagonal.
Oh, no, not in Algebra 1. That you're starting to get into some trig/pre-calc stuff on that. Because when you're starting to go at an angle, yeah, that's different. It's a whole nother thing. That's cool. Good example there. Okay, I want you guys to try with me. You can do it on your own. You can do it with me. Number 11 on page 237. Number 11 on page 237. Bless you. Okay. So here's an example of what you will get. Number 11, page 237. Okay, Ryan and Jessica Wilson leave their home at the same time. Ryan, sorry, I just lost my spot. In opposite directions as well. So Ryan and Jessica leave their home at the same time, traveling in opposite directions. Ryan travels at 57 miles per hour, and Jessica travels at 65 miles per hour. In how many hours will they be 366 miles apart? Okay? So I'm going to draw a quick diagram just to show you what's going on here. If you're not, I can't even picture that. Do they start at the same point? One goes one way, and the other one goes the opposite way. One is named Ryan, and one is named Jessica. And what are they trying to ask? How long will it be when they're how far apart? So that's my problem. And then I know, although I don't know what Jessica's distance nor Ryan's distance was, I know that the two of them added together will give me what? It's going to give me 366 miles. That's what I know it's going to have to get. So the distance of Jessica plus the distance of Ryan is going to have to equal 366. That's key. All right, and then the chart. I hope you guys are getting better at the chart, or at least feel better. Okay, so my chart here, I'll put it. It's 3 column, 2 rows. We have Jessica and we have Ryan. And we have RTD. What's the rate of Jessica? What's her speed? 65. Good. What's the rate of Ryan? 57. I have those spots. They left at the same time. So what do we know about their times?
They're the same.
Same. They're the same. And then, how do I find out those distances? 65 times t. And 57 times t, which gives us those. What do I do with those two numbers right there? And what should their sum be? Good, good, there you go. See, you guys are getting this. And solve for t. I know that's a t and that's a plus. I try to make the t's a little bit bigger than the pluses. For this problem, yeah.
Wait,
this is one type of problem.
12, though. That's hard.
Yeah, you're not doing number 12.
Thank you.
Wait, did you say number 12? Okay, no. You could try it, and as much as I would love to do all these, remember 4 into 2 of this type of problem, like of the distance uniform motion problems, but there's another type that's next. Yeah, I hope it's not too bad. Hayes?
So what this problem is saying is that there's a road that's 366 miles long, that's perfectly flat and perfectly straight.
Actually, Hayes, that does bring up an important question. Like, so when Jessica and Ryan left their house, did they automatically start going 65 and 57 miles per hour?
Oh, yeah.
In strict opposite directions? So I'm trying to think like, Route 66, maybe there's a straight. I don't think there is one. You know what? And take this with some maturity, and this is for Swivl as well. This doesn't happen. This does not happen. Remember who was it? Was it Josh or Benson that Benson, you brought up, are you ever going to do problems where they go like off to the side a little bit? Well, that's real life, isn't it? Ryan's driving, and he takes a turn. So he's going off at an angle. That's where you're starting to get into that pre-calculus, and I would say calculus, because this is not enough to describe real life. You need to describe it with calculus. But how do you get to calculus? You got to go through algebra. So you got to go through like the theoretical to get into the real.
Oh, I see.
That's which I think is cool because, yeah, this doesn't happen, but you can think of it. Yes, if it did happen, and now let's start adding those. And by the way, does anyone ever? And I'm going to ask this question, see if you really understand. Does anyone really ever go 65 miles per hour consistently?
No.
And then someone throws in, what about cruise control? Do you know how cruise control works? So you're driving, and it keeps at 65, but when it registers that your car is going up a hill, the speedometer drops a bit. Sorry for you guys. It drops a bit, and then it picks it back up. That little fluctuation is saying that you changed from 65.
And when you go down a hill and up,
It goes a little bit faster.
slows.
Exact. Faster, slower, it adjusts. So does any vehicle ever go 65 miles per hour for 3 hours? No way. Even like a truck that's going down a straight road will fluctuate. So that's getting into calculus. The rate of change and all that.
Straight road? It wouldn't.
Maybe. It's theoretical. I don't think so. Okay. Would it? I don't know. It goes like this. Because maybe there's a little incline, a little decline. So it just does that. So it never really stays perfect. All right, what's 65 plus 57? Good. And when you divide both sides by 122, you get t equals 3 what? Hours. Okay, that's 3 hours. So when they start at the same spot and they go opposite directions, theoretically, in 3 hours, they're going to be 366 miles apart. Does that make sense? Okay, so that's the uniform motion problem. Okay, last type. Now we're going to example number 2. So here's where you guys are saying, what about example number 2? It's right here. I'm skipping example 3. That's for another time. Okay, example number 2. I'm going to read it, and I need you to look at it while I'm reading it, because when I just read it out loud and you're just listening, I was like, what is he saying? Just look at it with me. Example number 2. An advertisement for an orange drink claims that the drink contains 10% orange juice. Okay, so someone doesn't like orange juice. Jamel needs 6 quarts of the drink to serve at a party, and he wants the drink to contain 40% orange juice. How much of the 10% drink and pure orange juice should Jamel mix to obtain 6 quarts of a mixture that contains 40% orange juice? Yeah. Jamel is picky, or maybe his guests are picky. I don't know. Now,
The fact that it's only 10% orange juice is just disgusting.
Yeah, that is kind of gross.
well, and it's if you look at your juices, they'll say it contains less than 1% juice, contains 10%, contains 40%. Oh, very few of them say 100% fruit juice, but even then, yeah, buy all those pure containers. All right, listen up, please. This problem is really for people to be so picky about their orange juice. That's a little extreme. But the next problem I'm going to give you is with chemical mixtures. And when you guys are in chemistry, and you're trying to mix up different things, you don't want a 10% solution, and you certainly don't want a 100% solution. You want something in between. Because when you mix that solution with this other solution, and it's too concentrated, things that are bad happen. That's why, as science teachers, we have to watch those videos of people washing their eyes and getting a bath, a chemical or a water bath after being exposed to chemicals. There is value to these problems, because you don't want to do 60% plus that. Boom, in your eyes, in your nose, on your face. You're hurting. You might die. So we want to orange juice. You won't die. You're just like. Some of you won't even like orange juice, whatever, but okay, we'll get to this one. All right, Jamel, very picky guy. We're going to do this one here this time. I guess, no, you know what? I'm going to make it easy for you guys. I'm going to make it 3 column again, and it's going to be 3 rows this time, 3 rows. These are chemical mixture problems. When it talks about percent this and percent that, you're talking about this type of problem. Okay. What percent mixture does Jamel want for his orange juice? What does he want? What percent does he want?
40%.
40%. And I hope you can get that from the problem. It says he wants a 40% orange juice. He has 2 types of orange juice. He has this percent and an unknown percent. Well, what's the first percent that he already knows? He has a 10%. And then it says he has pure orange juice. Do you know what percent orange juice,
100.
pure orange juice is? Yeah, it's 100%. Do you guys get that? Pure orange juice is 100% juice, if it's really pure.
Well, orange juice, if it's that concentrated, will it fall off?
Orange juice?
Yes.
I don't think so. Unless it's mixed with some chemical that reacts poorly with the with the acid, the acidity of it. Okay, anyway, I don't want to try it out. Okay. Then it says he has 6 quarts. He wants 6 quarts. Isn't that what he wants? 6 quarts? Okay. That's how much he wants. He wants to end up with 6 quarts. And the problem is asking me how much 10% and how much 100% should he mix together to get that 6? I don't know what these are right now, so we're going to have to describe them. So here I'm going to put the headings, percent of OJ. Okay, I'll put percent of OJ there. And this one I'll do what is it measured in? Milliliters? Or I think it's liters, isn't it? Liters. Oh, quarts, thank you. Some will be liters, milliliters, or quarts. So this one, thank you guys, is quarts. And then this is going to be your amount of OJ. And I hope you understand that there is a difference between percentage of OJ and amount of OJ. They're not the same thing. And actually, let me try to describe that real quickly here. Okay, I have a water bottle. And we're going to pretend it's orange juice. Okay, how much orange juice do I have in this bottle?
100%.
We're going to call it pure orange juice. Okay, pure orange juice. Pure. So it's 100% orange juice, right? When I take that, listen, when I take that orange juice, so this is all I have, it's 100% orange juice, and I fill it up with water, the rest water. It's still going to be orange juice. It's going to be, have you heard of the word diluted?
Yeah.
So it's not going to taste as strongly as normal orange juice. But it's going to be not 100% orange juice now. It's going to be like 20%, maybe 15% orange juice. But the amount of orange juice in here will be the same. Do you see how the amount would be the same? It's not like I took any out.
Yeah.
It's just going to be the percentage changed. So that's the difference between amount and percent. And if you didn't get that, it's okay. But I'll try it. Yes, that's water. Thank you. All right. Now, all I want you to do right now is I want you to assign one of these with a variable. It doesn't matter. So which one do you want and what variable do you want? Your choice. Kyra, go ahead.
Q.
Q for which one? Q. Thank you, Kyra. I'll take it. QT. Nice. All right. Anyway, this is what I know. Please listen up to me. Please listen up because this is going to be key. I know that this plus whatever this is going to equal 6. Okay? Just like whatever this is plus that has to equal that last row and column. Okay? Do you guys remember complementary and supplementary?
Sure.
What are two angles that are complementary going to add up to be? Complementary.
And 45 is 90.
Okay, those are two examples, but can you have 30 and 60?
I think
Okay,
so.
so watch this. Ready? Complementary, supplementary. Remember, x is a complementary angle. What's its complementary angle? It's 90 minus x. Do you guys remember that? This is what some of you did your bonus so well. If one of the angles is x, how would you find the other angle? You would do 90 minus x. Let me give you an example. If this angle were 30, what's 90 minus 30?
60.
So the other one had to be 60 because the two of them have to add up to be 90. So ready for this, guys? If this is q and the sum has to be 6, then this is 6 minus q. And I'll give you help with that, so just write that down. And don't give up. Don't be like, oh man, I don't get it. Please stay with me. Okay, ready? Let's say q was 1. Okay, let's say q was 1 quart. Can we say that? What's 6 minus 1? Is 1 plus 5 equal to 6?
Whoa.
Okay, I'll give you another example because some of you are like, wait, what are you trying to say? Ready? If q is 2, what's 6 minus 2? 4. What's 2 plus 4? So no matter what this is, yeah, you can do like 1.5. And then what's 6 minus 1.5? 4.5. 1.5 plus 4.5 is 6. Yeah. No, it's not me, it's the problem. It's complementary. Pause it. Don't listen to them, Swivl. They're trying to hurt me. No. They're plotting against me. No. All right, ready, guys? This is a question.
Yes. So you said you did it on the QT side? Or just the...
Oh, quart side, yeah. Okay.
Yeah, on
Quart.
the quart side.
Uh-huh.
Does it work on the percent of OJ side?
This side, you're always going to have all the percentages. So you don't have to worry about plus or minus. This you might have plus or minus, and this you could have plus or minus.
Okay.
So in this case, it's minus. Yes, sir.
Wait, what if it's...
Sorry, Hayes.
With the non-OJ, you go ahead and find one.
Yeah, go ahead. Go figure it out. But how do you find this column? What would be this column right here? It'd be, yeah, and how do we write 10% as a decimal? 0.1? 0.1 Q is the amount of OJ. Remember how we multiply? Okay, what's 100% as a decimal? 1. What's 1 times 6 minus Q? 6 minus Q. So far, so good. And then what's 40% as a decimal? 0.4. What's 0.4 times 6? Don't say what it is. It's just 0.4 times 6. That's what it is, 0.4 times 6. Okay, ready, guys? Here's the application. My chart is filled. And now, I know that this plus this equals that. We already demonstrated that. And I know that this plus this should equal that.
Wait. This plus this equals what?
That. The first two rows equal the third row. Okay, ready? 0.1 q. So write this down. 0.1 q plus 6 minus q equals 0.4 times 6. Okay, I'm not sure about it. That's what I say it is. And you're like, okay, I kind of believe you. But let's figure it out. Write this down. Everyone should be writing it down. I know you guys are tired. I get it. I'm tired too. My head right now is pounding. It wants wings and water. And not necessarily in that order. Okay. I had some already, which is helping me not to have my head explode. All right. Okay, is this simplified? Well, no. You see this term and this term? Can they be combined? Yes. Look at this problem, please, very, very carefully. Isn't this negative 1q? Over here, negative 1q? What's negative 1q plus 0.1q?
Negative 0.9.
It's negative 0.9q. For those of you who are like, no, that's not possible. Okay, these two have to be added. That's a negative, that's a positive. So you still do 1, which is right here, minus point, sorry, it's, what you know what I mean, 0.1, which would be 0.9. 0.9, sorry. Well, it's messing up on me, so. 0.9q. But if the negative was bigger, it's a negative value here. Negative 0.9q. Sorry. Plus 6 equals, oh my, oh. It was doing so well. And this happened to me yesterday. Was it with you guys? No, it happened with the other class, but the board starts giving me trouble. So maybe it's my marker. What's 0.4 times 6? Just do what's 4 times 6? 24. And then the decimal goes right there. It's 2.4. Now solve for q. What do? You look at what's happening at q. It's being multiplied by negative 0.9 and added with 6. So what do you do to both sides first? Subtract 6. We're going old school here. Negative 0.9q plus 6 equals 2.4. All right, I'm going to subtract 6 from both sides. And that cancels out. I'm left with negative 0.9q right here. And then, can you guys subtract that out properly? Why? Wait, negative? What? If you line up the decimal places, you notice you do not do this 0.4 minus 6. That is not the problem. You do not do 4 and then get 4 here. It's not negative 4.4. And I've seen that too many times now. You have to take the bigger absolute value and subtract the smaller absolute value. And so you get here 5, 6, 3.6, 3.6, and it's got to be negative 3.6. Okay? All right, last step. And you're like, man, this is too hard. No. Just work it out. Write it down and work it out. You're like, I can't do this. What's a negative times divided by negative? It's positive, so I'm done with those signs. And then you're like, 3.6 divided by 9, 0.9 even. That's not even just 9. It's 36 divided by 9, which is what? 4. So what does the q equal? It equals 4. Okay, ready for this? Is that really the answer? I don't know. So I'm going to circle that. All right, q is 4. What's this then? What's this worth? 2. And is 4 plus 2 6? That has to be the answer. Quarts. No. Not me. No. Sorry. Thank you, though. I do have a...
Wait, you have a what?
I had a question. Did you have your hand up?
I was going to say quartz.
Okay, quarts. Thank you.
Yes.
Wait, hold on.
I have a question here.
Period at the end of T. So it's
There.
Thank you, Rod. All right, anyway, let me give you the homework, and then I'll work some out with you. Yeah, 6 problems. Wake up. Whoever's asleep, wake up. Once you get this paper, you can start working on them, but you can work with me as well. Who's Miss? Is this Ellie? Margot, thank you, yes. And then she got sick.
Your name is Swivl.
Take one, give it to your neighbor. Okay. I'm going to say this once, and I'm saying it into Swivl so it can be recorded in time. I want to help you. Either I gave you 6 problems with no help and just say, go do it, have fun. Or I can do maybe 1 or 2 problems, and then you could do 4 problems with a little bit more knowledge. This is your choice, but please, let's not goof off here because I want to help you out. So if you're like, I don't need your help, Mr. A, that's fine, but please don't distract others who might need the help. All right, I'm going to do number 1. Did you guys notice on these problems there are 6, 4 in the front, 2 on the back, that there's a little number written EX2, EX2, EX1, EX4? If you're at home and you're like, I don't remember anything about number 1, it's referring to example number 2. So that's how you can figure it out. EX4 is example number 4. On the back, there's a number 9. That's problem number 9 on page 237, the coin problem. So we've done all of those examples, and you can refer back to them to look at this problem. All right, I'm going to do number 1, though. I think that's the toughest one. Okay, Nicole wants to make an 18% alcohol solution. Now, before you start laughing and getting too lost in your daydreams, she's making medicine or she's making some substance that can clean. It does not have to be drinking alcohol, okay? So just to let you know. Anyway, she wants to make an 18% alcohol solution. She has already poured 8 liters of pure water into a beaker. Normally people don't drink out of beakers, but that's up to you. All right. How many liters of a 30% alcohol solution must she add to create this desired mixture? Okay. I'm going to start off with my table here. I have my 3 columns, and I'm going to have my 3 rows because this is a chemical mixture problem, and just like example number 2, it had 3 columns and 3 rows, a 9 by 9. All right, listen up carefully. What percentage does she want of alcohol?
18%.
Okay, that goes in here.
Yeah.
That goes right in there, the bottom left corner. That's what she wants. By the way, this is what they want at the end. It's always that bottom row. This is the tricky part. Do you guys see that she has to add 30% alcohol? A mixture of 30% alcohol? So I'll put that. And it can go here or it can go up here. It doesn't matter where the spot goes. But this is the tricky part right now. She has already poured 8 liters of pure water into the beaker. So let me ask this question. Ready, guys? What % alcohol is pure water?
0.
0%. It's just water. It's not alcohol. This is going to be the percentage of alcohol. This is going to be, and is it liters in this one? Liters?
Yes.
Okay, and then this is an amount of alcohol. Amount of alcohol. All right. Does it say anything about the amount of liters in this problem so far? What does it say?
8 liters of water.
8 liters of the pure water, which is the 0% alcohol. So that's 8. Goes right there. 8 goes right there. Do I know how much of the 30% solution she's adding? No. So I'm going to put X. I don't know it. Okay, do you guys remember what should go right here?
8 minus X?
Close.
X minus 8.
Close. I hear it. 8 or X plus. So they're added together. Remember, this column is always the addition of the 2. This last row, I should say, is the addition of them. Yeah, remember the last one we had like 8 minus X over here? That can go in these 2 spots. It's not going to go in here.
I think now I can figure it out.
Now, what is the amount of alcohol? If it's 0% alcohol with 8 liters, you know how it's still 0. She didn't have any alcohol in that pure water. Right?
Correct.
0%? And then this one right here, well, what's 30% as a decimal? 0.3 times x, 0.3x. And then the last one would be 0.18 times 8 plus x, right? You guys remember that? You're just multiplying these two together. Don't forget it's a quantity. You got to put those parentheses somewhere. Okay, the equation. This is it, and this is where you start solving. This plus this equals this. Yeah, this. So 0 plus 0.3x equals 0.18 times 8 plus x. I know it's a mouthful, but basically I'm just writing down what was already up there. And you're like, man, mister, you got to be kidding me. We've got to work this out. Watch. Do you need the 0 anymore? No. 0 plus anything is just that anything. So now that's my equation. But now I'm dealing, decimals. All right, I'm going to write the decimal down. And then some of you are thinking, I can't do 0.18 times 8. What you have to do is this. You do 18 times 8. And that's 144. How many decimal places did you have? 1.44. 1.44. That's not scary, is it? Okay. And then 0.18 times x is 0.18x. It's deep. Okay. Is that able to be solved? Not as is. Because you see how I have an x on one side and on the other? So now this is where you have to use your math number sense. I want to get the x over to the right or to the left, your choice. One's going to be easier than the other, depending on how you view it. So really, either way it goes. Okay, ready? Which one of these quantities is smaller, 0.3x or 0.18x? Smaller. Go ahead. This is smaller. Okay? And you're like, wait, how do you know that? This is 18 hundredths, and this could be called 30 hundredths, if some of you are thinking decimals. All right, so I'm going to subtract 0.18 from both sides. Subtract 0.18 from both sides. Okay, gets that canceled out. And here you must be careful. You're subtracting two decimal numbers, so what do you have to line up? The decimals. So it's 0.30 minus 0.18, which gives me a... That's okay, 0.12x. Because you got to line up those place values. And that still equals 1.44. Oh, no. 0.12 into both sides. Not a hard problem. It's going to give you a whole number, and this whole number is going to be... I think I heard it.
Liters.
Yeah, 12 liters is your answer on that one. That actually, you don't need the period on these. You can. This one you don't. You can actually, yeah, like here, 500 milliliters is ml, and so liters would be the same. But anyway, for some of you who can get this, I want to see if you guys can pick this up. Try it if you can. If you can't, it's okay. It's good to listen to. All right. Do you see how she wants to get 18% mixture? She has a 0% mixture and a 30% mixture to mix up together, right? Is 18 closer to 30 or 0? It's a little bit closer to 30, right? So doesn't it make sense that she needs a little bit more of the 30% mixture than she does of the 0% mixture? And that's all I'm going to leave at that. This is a proportion. Okay, this is a proportion. And if you're like, I don't know what you're talking about, that's okay, but that's how it ties in together. Okay, we're done with number 1. The next hardest one, I think, would be, I think it was, I guess it depends. Well, how do you guys feel on this, by the way?
Not ready for a test or quiz or nothing.
Don't worry, you don't have one.
The percentages are way harder than the other ones.
Okay, let's do number 2 then. Let's just go to number 2. You have one on the back that's number 5, but I hope you can get it by then. All right. So I think we have time to keep going here. All right, who can read for me example 2? Michaela? Yeah, go ahead, Beth.
Michaela wants to make a 46% alcohol solution. She has already poured 9 liters of a 7% alcohol solution into a beaker. How many liters of of a 85% alcohol solution must she add to this to create the desired mixture?
Okay, so we've now 2 problems in a row with alcohol. Don't worry, on the back it's pineapple juice.
Yeah, why are these
So we're gonna get one.
questions?
Do you remember what alcohol is used for? Cleaning,
Yes, but why?
sanitizing,
Nullifying.
nullifying. Oh my. Okay. Okay, what percentage does she want? What percentage does she want?
46.
She wants to make a 46% solution. And we're talking about percentage of alcohol. And yes, this is alcohol today, but tonight it's going to be pineapple juice. You can do that at home. All right. What percentages does she have?
7 and
7% and an
Or under.
85%. You see that 7%? She has already poured 9 liters of a 7%. How many liters of a 85% does she want? Okay. All right, guys. And this is a cool problem. It's really a cool problem. This number is actually very close to being right in between both of these. Hint, hint. Okay, anyway. Do we know anything about the number of liters of any of these? 9 is 7%. That is correct. Do I know how many liters of the 85% she has? No. Do I know what the total is going to be?
X plus 9.
Oh, thank you guys. X plus 9.
You're welcome.
And then, go ahead and work it out. It's going to be a number that is nice. Now, it might be a decimal. That's okay. It's not going to be a repeating or, well, just work it out. No. If it's repeating, it'll be like 0.6666. So you just round it to the 10th, 0.7. So don't feel too bad. But anyway, I'm starting to mix all these problems together myself. Mix them together. Oh, look at that. Oh, yes. Thank you. Swivl. Goodbye.